Good afternoon. In this talk, we will give an overview over the TURNkey project, which is an EC financed project, and I'm the project coordinator, and Ivan van Bever is the project manager. The full name of the TURNkey project is Towards More Earthquake-Resilient Urban Societies through a multi-sensor-based information system enabling earthquake forecasting, early warning, and rapid response actions. The project has a duration of 3 years, and we are now in the last year. And the TURNkey consortium consists of 21 partners from 10 European countries. The partners are universities, industry, and research institutions. And the total volume of the project is 8 million euro. In the following, I will give a short description of the project. The objectives of the TURNkey project follow a typical timeline of an earthquake crisis. Before the earthquake, we collect and analyze earthquake hazard information. The operational earthquake forecasting. After an event, we distribute as fast as possible and as reliable as possible alerts, the earthquake early warning. And then most probable damage scenarios are calculated and distributed to the relevant stakeholders, the rapid response to earthquakes. For this, we developed the TURNkey platform. Low-cost multi-sensor units, conventional seismic networks, smartphone-based networks, they all contribute in and send in near real-time data to what we call the TURNkey engine. The TURNkey engine consists of a suite of programs which are analyzing the input data based on earlier and predefined parameters and information. The engine is communicating together with a platform operator via the cloud with the TURNkey users. The TURNkey users can be or are public authorities, decision makers, first responders, private companies, or any general business interested in this information. To develop and to test the TURNkey platform, we have chosen 6 geographical testbeds in Europe. In Romania, France, Iceland, Greece, Italy, and the Netherlands. And in these testbeds, we have installed approximately 160 TURNkey seismic sensor units, which are Raspberry Shake 4D or GNSS sensors. And the geographical distribution of the testbeds had been made to achieve a wide range of spatial extent, levels and types of existing monitoring systems, population densities, and types of vulnerable infrastructures. The project is subdivided in 8 work packages. In work package 1, we analyze the end user requirements and wishes with respect to such a platform or such a product. Then work package 2 is related to the real-time data from testbeds. We have a suite of testbeds where we are testing the platform and the multi-sensor units. Then work package 3, 4, and 5 are combining and developing the algorithms which are then installed and implemented in the engines. Then in work package 6, all this information is set together and the engine and the platform itself are built together. And finally, we have work package 7 and also partly in work package 6. We are exploitation and dissemination of the results again to the public and analyzing how they are now seeing the results of this whole project. And then we have, of course, a project management work package. These were the plans of the project, and now we want to report about the actual status of the project. To understand better the end-user requirements, we performed interviews with the different stakeholder groups, and the main result of these interviews were a common non-academic language to be used in the platform, then a common understanding of the design and operational expectations from the platform, and use case scenarios. The end-user requirements are tested through a participatory action research cycle approach organized in 3 iterations. The turnkey instrumentation has been installed in different environments at the different testbeds. The Raspberry Shake instruments are 3-component accelerometers and have 1 vertical seismometer and are optimized for earthquake early warning and multi-sensor connectivity. And they are streaming the data in near real time to the platform. The GNSS instruments are measuring the 3-component displacement, and they are also transmitting their data via the Raspberry Shake units to the platform. And what we can see here are some pictures from some of the installations. For example, here a Raspberry Shake in a basement, the GNSS instrument installed in a harbor, then the GNSS receiver, how it looks like as turnkey instrument now, then the Raspberry Shake in a box, a free-field GNSS installation in Testbed 3 and in Testbed 1 in Bucharest, installation in a house to measure structural changes due to an earthquake. As said before, in work packages 3, 4, and 5, the methods and algorithms had been developed to be installed in the platform. For this, first we performed a state-of-the-art investigation worldwide and compared ideas from different installations. And then the algorithms were chosen and partly new developed, and new methodologies had been developed related to hazard and risk models and the decision support systems. And by this, we were focusing on the short-term changes in seismic hazard, quick determination of source parameters, improved and efficient data communication, rapid loss estimation, and improved emergency actions. Until now, already 26 scientific publications have come out of this work. And all this is then implemented in the platform. A better version of the turnkey platform we presented in November 2020. And last May we could show and demonstrate version number 2 already on a TI level of 4, and we hope that the final version on a TIL level 5 will be ready in January 22. And in conclusion, we can say that the cloud-based turnkey platform can integrate data from existing and conventional seismological networks, strong motion networks, structural monitoring systems, GNSS sensors, as well as smartphone-based networks and observations from eyewitnesses. It allows a near real-time analysis of all this input data and provides actionable output for stakeholders. And thank you for your attention.